Alrighty, algebra. So we're going to be working on simplifying radicals. Now, we've talked about where quadratics are going to be used and why quadratics are useful in life. And we're going to do a lot more with that. But we're going to be working on what we're calling simplifying radicals, which means square roots like this. And we need to be fully honest. Right away, if you get to the point where you go, why in the world do we have to do this? Where in my life would I simplify radicals? The truth is, you won't. You'll deal a lot with square roots. You're going to deal a lot with quadratics, that type of thing. But the truth is, radicals themselves are not terribly important. So why do we have to learn them? Because they teach you good critical thinking and problem solving. Okay, so this is not a real world skill. There's not going to be any real world problems and things like that. It's just going to be, let's learn the concept and get through it. Okay, so perfect squares list. This is one of the things you should have down. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and so on. You should have this list already made as a similar thing. Maybe 1 squared is 1, 2 squared is 4, that type of thing means the same thing. If you need to remake the list, you need to do it now. Okay? So when we have a problem like this, the square root of 50, we cannot give an answer to it until we break it up. So what we're going to be doing is we're going to change the square root of 50 into the square root of one of these perfect squares here times 50. So you have to think to yourself, what number times 50 is a perfect square? And I hope that the number 25 jumped to your mind. So if we put 25 here, we can go 25 times 2 is the same thing as the square root of 50. They're exactly the same. Now, a rule of square roots means that if we have the square root of one thing times something else, we can change that into the square root of 25 times the square root of 2. And Nicole's already jumping, saying, can I skip from here down to here? Absolutely, that's just fine. But now that we have this problem, we know that the square root of 25 is 5. And now we can change this into 5 square root of 2. And that's our answer. Now, 5 square root of 2 is the same thing as the square root of 50. And we know that because if we took out a calculator and we typed in the square root of 50, it would give us this ugly decimal, 7.07. But if we did 5 times the square root of 2, it should give us the exact same decimal. And it does. So we've done it right. That's how we know we've done it correctly. This right here is the simplified version. So when it asks you to simplify this radical, it wants you to simplify it down like this, get rid of all the perfect squares. So over here in the square root of 48, we have to think, what perfect square can we pull out of 48? And I hope, if you go back here and look down this list, you see that 16 can be pulled out of 48. And it becomes the square root of 16 times the square root of 3, which we can then break up. Square root of 16 is just 4, and the square root of 3 is just 3. So there's our simplified answer. Now I want you to try these on your own. Okay, they're going to be a little difficult, and that's okay, but give them a good try, and then I will walk through them. Okay, so I hope you gave these a try. This one on the left should have become the square root of 25 times 3, which is the square root of 25 times the square root of 3, which is 5 square root of 3. And over here, I think we can pull out a 4. Oh, we could also do 36. I'm going to pull out a 4. Would that work? 180 divided by 4. Okay, that works. I'm going to do 180. I'm going to do this as 4 times the square root of 45, which gives me the square root of 4 times 45, which is 2 square root of 45, which seems like the answer, except that 45 isn't done yet. This can also be split up, so I leave this as 2 square root of 9 times the square root of 5. This is 3, so it's 2 times 3 times the square root of 5. 2 times 3 is 6, square root of 5. You also, at this point, could have broken this up and do the square root of 36 times the square root of 5. That would have worked out just fine, too. Okay? Now we can do the same thing we've been doing, except we can then simplify from here. Now, I recommend that you should always simplify inside the parentheses first if you can. I see numbers that can be divided by 2, so I'm immediately going to divide by 2. So I'm going to change this into square root of 16 over 32. Okay. Oh, sorry, over 25. And now I can do another rule in square roots. If I have something that's the square root of one big thing, I can make that the square root of 1 over the other, like that. So the square root of the whole thing becomes square root of 16 over square root of 25. Square root of 16 is simply 4, and the square root of 25 is simply 5, and that's our answer. If I type this into a calculator, I would go the square root of 32 divided by 50, close the parentheses, should be the same thing as 4 divided by 5, which it is, so that one works. This one on the left, I don't see how we can simplify it, but we can break these up into 2 pieces. The square root of 75 on the top can become 25 times 3, and on the bottom we can do 48 can become the square root of 16 times 3. When I break these up, I can get the square root of 25 times the square root of 3, and over here I can get the square root of 16 times the square root of 3. Rules of fractions, if we have the same number on the top and the bottom, we can cross them out. So then I get the square root of 25 over the square root of 16, which is 5 over 4. And we can check that and get that answer. Okay? I want you to try these on your own. How are we doing for time? We're a little long, but that's okay. We're almost done. Here, I can break this up into the square root of 9 times 5 over the square root of 16 times 5, which ends up being square root of 9 times the square root of 5 over the square root of 16 times the square root of 5. I can cross out these because they're in the top and the bottom. Square root of 9 is 3. Square root of 16 is 4. And that's our answer. On the right here, I can divide the top and the bottom by 2 right away to give me 25 over 50. The square root of 25 over the square root of 25 times the square root of 2. So I can cross these out and end up with 1 over the square root of 2. Now, this problem right here leads us to what we're going to learn next. You cannot ever have a square root in the denominator, which is the bottom of a fraction. So what do we do if we have the square root in the denominator? Like we have a problem, actually, let's just do this one. Let's do 1 over the square root of 2. If we have this, we then do what we call rationalizing the denominator. That's terrible handwriting. I'm sorry about that. Rationalizing the denominator. We are going to multiply by the square root of 2 over the square root of 2 because this thing right here is technically a value of 1. You can always multiply by a value of 1, so that's what we're going to do. Now, if we multiply by the rationalizing the denominator square root of 2 over 2, we would get 1 times the square root of 2 on the top, and on the bottom, we would get the square root of 2 times the square root of 2, which would be one of 2 things. It's either going to be is equal to 2, or it's going to be equal to the square root of 4, which is 2. Same thing, square root of 3 times the square root of 3 is 3. The square root of 16 times the square root of 16 is 16. Okay, same thing. So this ends up being 1 square root of 2 over 2 times 2. You always will multiply by that square root on the top and the bottom. Okay, so last slide, give these a try and see how you do. Alrighty, so let's see how we got here. This one, we end up getting the square root of 1, which is 1, over the square root of 3. So I got 1 over the square root of 3. I then rationalize the denominator by going square root of 3 over the square root of 3. So I end up getting 1 square root of 3 over 3. And I'm done. Here on the right side, this can be the square root of 9 times the square root of 3 over the square root of 3 times the square root of 5. So these can go away, and I end up with 3 over the square root of 5. So I have to rationalize by multiplying by the square root of 5 over the square root of 5. So I get 3 square root of 5 over 5. Alrighty, these take practice. I'm not expecting you to be a master at these. Just be ready to practice them in class. These are 2 days assignments. This right here is day 1, and this right here is day 2. Okay? This is going to be on Wednesday. This is going to be on Thursday, and these are all in class. Bring your notes for this video with the problems we did in pausing. You'll get your points Wednesday. Wednesday and Thursday are both work days, and then looks like we'll have a quiz over the weekend. Alrighty, have a great day. We'll see you tomorrow.